Okay. You ready to record, Neil?
Yeah.
Hi.
Hi, Kip. How's it going?
It's good to meet with you. Hello, friends. This gives you context. Neil Beesley and I are meeting in the midst of COVID era. Neil, why would I have a conversation with you? Why would I choose to sit down and talk with you? Can you give a little bit of your background on mainframe development and tell people who you are?
Yeah, before I started on assembler programming, I worked for Rolls-Royce Aero Engines, so there was a lot of design, but that was very different design. And I moved from there to work for a German software vendor that was very big as a mainframe software company, and they told me more or less from the interview, you're going to do everything in assembler. You might do a little bit in a 3 or 4 GL, but for the time being, you're going to have to become good at assembler. You're going to have to teach yourself. We'll help you. So from there...
No, tell me more about that, Neil. How long how long did they give you to do that?
Oh, it was pretty open-ended. We worked in offices of maybe 2 or 3 people.
Okay.
So you would always have someone with 10, 15 years. What I did while I was working for that software products company, German company, I got around the database and the language, the 4GL language. It was all mainframe. And then I got into the middleware and I started learning how do you connect ZOS? How do you connect a mainframe efficiently to client server?
Yeah.
To Windows, it was Unix then, but that became Linux.
Yeah, yeah.
And so I didn't stop doing it.
But you were then had to learn all the other platforms in order to talk to the mainframe.
Yeah, so I was programming on AIX and various other platforms at that point.
Yeah.
Which is kind of I haven't done that for a long time.
No, but it's good to broaden you. It's good to have a breadth of abilities. It helps you. I found when I learned a new language that I understood English better because I'd learned a new language, and I understood the differences, and so understanding multiple platforms allows you to understand computing in a better way, in that same way. So let me say one thing why Neil had been helpful to me this year. When I meet with Neil and I was explaining to him a whole bunch about Geneva ERS and Sapper, when I throw out a little idea of, we could ultimately do this, Neil's not one to just kind of sit around and say, yeah, we should put that on a plan and maybe someday get around to it. Neil would say, well, how do we do that? And so I found myself saying, okay, I need to follow Neil's. He's got energy here. He's helping me investigate this space more thoroughly. So I would set up every Friday, I say, Neil, can we meet in the office at 10 or 11? And I'll teach you what I know and we'll talk about stuff. But every week it'd turn into, well, what can we do about that? Okay, well, I'll follow your lead.
Or should we try it?
Should we try it? And so it's been very helpful to me. Neil has been very encouraging to me to do this experimentation. I want to compliment you. I complimented him in an email this last week.
I appreciate that.
No, it was great.
You don't always get thanks for wanting to experiment.
No, but it's been very helpful because it's generated energy, and it's these insights that you're getting here about Spark, Apache Spark. I had most of that knowledge, but I hadn't articulated it in the clarity of going through it with Neil and the winnowing down of the idea more clearly through the process of experimentation, where we didn't. A few months ago, I don't know if you'd be willing to share this, and I can edit this out if you don't. But you shared with me the funniest mainframe story. I literally was in tears.
There's been a few.
But the one that you shared was around a company that tried to get rid of, there's an old version of the mainframe.
Oh, MVS 0.3.8.
It's the last version of what became ZOS. MVS is the predecessor to ZOS. It's the last version that was not copyrighted by IBM. So it's available for use in, and it's free. It's open source. I mean, it's freeware. You can find it on the internet. You can find the source code, and you can find compiled versions of it, and you can run it under an emulator called Hercules. It'll be a virtual machine that runs on multiple platforms that gives you a mainframe on a platform. But sometimes when you get into mainframe, people with deep mainframe experience, you get into older stories about how, well, let me say it slightly differently. One of the things that I've done this last year is I bought a Raspberry Pi, which is a very small little machine, very small computer that was developed because people were no longer feeling comfortable to go get down and play with the machine at the hardware level to break their machine, because your computer that you use for your home, your billing, your whole finances are tied into it, your communication, your social life, so much that you don't go mess around with your own PC anymore and change basic settings in the computer that might break it. So the Raspberry Pi Foundation made this little tiny computer that's $60 so that people feel comfortable buying one of these and messing around with it, right? That sort of experimentation is important. In older days, there were mainframers who would do that kind of experimentation with a mainframe. One of the things that you talked about was that a commercial company tried to use that version as their production system, but they ran into problems with the disk drives.
Oh, yeah, because
Can you tell us about that?
Yeah, that version only supports 3350 DASD.
Those are very old.
And unfortunately, 3350s aren't available anymore. Oh, there was a way to, basically, this is more at the microcode level. There was a way to make
Let's describe microcode.
Okay.
I don't know if everyone will know what microcode is. Can you describe what microcode is? What layers?
Now we have to go into the channel. Yeah, the basically your I/O drivers. We managed to put something together. This was nothing can't claim credit for any of this at all. But as a company, we managed to put together, with a bit of help from overseas.
We had to find somebody, and the only person you could find was from South Africa.
We found, and we paid for him to come over and do what was needed.
Because South Africa had been going through apartheid, which meant they couldn't import anything, so they had figured out how to save very old systems and keep them working.
Yeah, they basically knew how to re-engineer anything. So we took our 3380s and slapped software, driver, basically software on them.
This guy came and wrote microcode.
Well, he brought some, but he still had to make changes while he was here.
Right, yeah.
While he was there in the UK. And he made our 3380s look exactly like 3350s so that we could bring up this
very old version of the operating system. But the guy only spoke.
He spoke Afrikaans, yeah. So, but we had a colleague who lived in South Africa.
There was only one other person in the company that was translator.
He was fluent in Afrikaans, so he got the job of spending time with him. A very, very smart guy was that came over.
I'm sure he was. Yeah. Okay. So, if you're interested in doing some experimentation with Neil, Neil's not afraid of that sort of experimentation. And then you get a sense why every time Neil, well, how do we do this? Okay,
let's try it.
Let's try it. There's nothing to be afraid of in here. Well, that's plenty of grist for the mill, I think.
Thank you.
We'll see what comes out of our conversation, what is useful to people. It's been a pleasure to meet with Neil today. Thanks for your time, and thanks for joining me on this conversation with Kip.
Thank you.